ladies and gentlemen.
So let's talk the quadratic formula. So quadratic formula is a very fancy formula, very overhyped, where no matter what standard form quadratic you're given, you can always find the solutions, real, imaginary, rational, irrational, doesn't matter. The reason why I say it's a little overhyped is because people tend to use this as the one end-all be-all method to solve quadratics, even the really, really simple ones that they could have just easily solved by factoring. The formula itself is the roots, the solutions are equal to negative b plus or minus the square root of b squared minus 4ac all over 2a, again for quadratics written in the standard form of ax squared plus bx plus c equals 0. Has to equal 0 for this to work. It is a formula, it's an algorithm. You have to be able to simplify using your, please excuse my dear Aunt Sally, the order of operations. Besides that, it's a really just plug in, simplify, there you go. So let's try a problem. So first and foremost, I notice that I do not have an equals 0, so I'm going to subtract the 19 from both sides so that I have 4x squared plus 4x minus 19 is equal to 0. This is my A, this is my B, and this is my C. A common thing I have seen in the past is that a student will involve the x's when they plug in the A, B, and the C. It's just the coefficients and the constants, just the numbers. So our solutions are equal to negative 4 plus or minus the square root of 4 squared minus 4 times negative 19 all over 2 times 4. Let's clean this up a little bit. 4 times 4 is 16 times 19 is awful. So we have 19 times 16. So 9 times 6 is 54. 6 times 10 is 60. 10 times 9 is 90. And 10 times 10 is 100. If we add all those together, we get a 4. 5 plus 9 plus 6. 6 plus 9 is 15, plus 5 is 20, so 0, 2, 2 plus 1 is 3, so 304. So we get negative 4 plus or minus the square root of 16 minus 304 all over 8. 16 minus 304, plus, we have a negative times a negative is a plus 304. So we get 304 plus 16, which is 320. Now we can factor this into a factor tree. Try to break off as many squares as we can. I know that this is divisible by 16 because 32 is divisible by 16. So this is 16 times 20. And then 20 has a square in it, which is 4. And then 5 is left over. The square root of 16 is 4. Square root of 4 is 2. 2 times 4 is 8. So this turns into negative 4 plus or minus 8 square root 5 over 8, which simplifies down to be negative 1/2 plus or minus the square root of 5. So because we got square root of 5 in our answer, it means that our quadratic here would not have been factorable because we got an irrational solution. So helpful in that case, but again, if you're able to factor, I highly recommend factoring instead. For this one here, you notice we don't have a b term. We have 9x squared plus 0x plus 25 is equal to 0. So where we plug in b, we're going to get a 0. So x is equal to negative 0 plus or minus the square root of 0 squared minus 4 times 9 times 25 all over 2 times 9. Well, this is going to cancel out. And then we have negative 4 times 9 times 25. Well, negative 4 times 25 is much easier to think about. We would have a negative 100 times 9 is negative 900. And if that's under our root, we need to factor tree this. We'll have a negative 1 and a 900. And 900 is actually a square, because 900 is 30 times 30. So we can actually square root this to get a 30 times negative 1. We would have negative, well, we wouldn't have negative 30. We would have an I. So 30i. So this would be x is equal to 30i over 2 times 9, which is 18. We can reduce this. All of this has a factor of 6. So that would be 5i over 3. Plus or minus, because we have that plus or minus symbol there. Now, yes, you can actually do this in a different way, and I want to do that with you now. We have 9x squared plus 25 is equal to 0. If we don't have a b term, it's far easier just to solve this by subtracting 25. 9x is equal to negative 25. Then I can divide by 9. X squared is equal to negative 25 ninths. And then I can square root both sides. And when I square root both sides, I would add that plus or minus the square root, negative 25 over 9. The square root of the negative is I. The square root of 25 is 5. The square root of 9 is 3. So we get that x is equal to 5/3 I, positive or negative. We get the same exact answer, but a lot less work and a lot less time. So pick your poison there. The last one we can also solve using the quadratic formula. We move everything to one side, so we get 6x squared minus 4x plus 0 is equal to 0 if we want to write in standard form. So our c is 0 here. So we would have x is equal to positive 4 plus or minus the square root of negative 4 squared minus 4 times 6 times 0 all over 2 times 6. Well, negative 4 squared is 16. This becomes a 0, so we have 4 plus or minus 4, because the square root of 16 is 4 over 12. So we have 4 plus 4 is 8 twelfths, which is common factor of 4 would turn into 2/3. Or we have 4 minus 4, which is 0 over 12, which is 0. So we get x is equal to 2/3 or 0. I was going to spell it out. Oof. So not too bad with the quadratic formula, but again, you can solve this one. So if I rewrite it over here, we had 6x squared equals 4x. Well, I can clearly see that if x is equal to 0, then it's true. So I'm going to have that one case. That is case 1. If x is equal to 0, then x is equal to 0, and that works. Case 2 is if x is not equal to 0. Then what I can do is I can actually divide by x. 6x equals 4. And then divide by 6, x is equal to 4/6, which gets us that 2/3 that we had before. So easy to do either way, and in fact, some of your math teachers might not even like this one. They may ask you to do 6x squared, subtracting the 4x over, so negative 6x squared minus 4x is equal to 0. Factor out the common factor of 2x, leaving us with 3x minus 2 is equal to 0, and you can see that 0 would make this factor 0, and 2/3 would make this factor 0, and solving it that way. So that one kind of has 3 different ways to think about it. My brain tends to one of these two, because in my brain that's just easier to do than automatically going to the quadratic formula. But hypothetically you could. It's just going to eat a lot of your time away, especially if you're taking a timed assessment, or you're just in a class where there's just a whole lot going on and you don't have the paper to spare for doing the quadratic formula. Anyway, it is again x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. My teacher in the past sang that to me in the tune of Pop Goes the Weasel, and it scarred me for life. Not going to do that to you. So Hopefully you have some way to remember it. Otherwise, good luck with your practice. If you have any questions, let me know, and I'll see you in the next video.